Problem statement. Suppose you are a quality manager at a company and you just received a truckload of 10,000 mangoes from farmers that are living all over the country, north side, west side, east side, and south side. And your boss says, "Hey, I want you to go and check if the shipment is good enough so we can export these." Now, clearly, you cannot cut open all the 10,000 mangoes. That's not possible, right? And you only have time, let's say you have time to just test 50 mangoes. So, how will you pick up those 50 mangoes so that your decision represents the whole truckload? Is it A, simple random sampling? Is it B, systematic sampling? Is it C, stratified sampling? Is it cluster sampling? Is it judgment? Or is it convenience sampling? This session is about discovering and answering these types of questions. By the way, the answer for this is stratified sampling. So, what is sampling and why do we even need sampling? Well, sampling is the process of selecting a small subset from a larger group. So, let's say this is your population right here. All this thing, this represents everybody in it. And you want to know maybe the mean, maybe the variance. It could be any statistics. So, what you do, you take a small subset of that. And this small subset would be your sample right here. So, population is the entire group that you want to study. A sample is a smaller group chosen from the population, maybe 500 students selected from different colleges, if your population is all college students in a country. Now, why do we even need sampling? Well, because sometimes collecting data from an entire population is it's not possible, it's not practical, or it could be very expensive. So, for example, a drug manufacturer, and he just came out with a drug, and he wants to test the side effects of the drug on the country's population. Well, it is impossible for him to conduct a research on everybody, right? It's not possible. So in that case, what the drug manufacturer does, he takes a sample of people from each demographic region and he tests the drugs on those people. So here's a fun fact about sampling methods. uh, in 1936, there's a magazine, Literary Digest. They mailed out millions of surveys to predict like who is going to win the presidential election, and they were very wrong. And they predicted some guy named Alf Landon that he's going to win by landslide, meaning he's going to win by a big margin. But it turns out it was Franklin D. Roosevelt who won by a huge margin. Well, why was the magazine wrong? Where exactly they went wrong? Well, the magazine sent surveys only to people who had cars, telephones, or magazine subscriptions. So, mostly wealthier citizens, and they ignored the poor voters. And these were the ones who decided the outcome of the election. So, even with millions of responses, your sample in this case was biased. So, what are the types of sampling method? There are two types. There's a probability sampling, and then there is a non-probability sampling. In your probability sampling, every individual in the population, they have a non-zero chance of being selected. This one actually helps avoid bias and supports statistical inference. On the other hand, your non-probability sampling, not everyone has a known or equal chance of being selected. This often leads to bias, and generally, they're used when your probability sampling is not possible. Further, your probability sampling is divided into four categories. You have simple random sampling, you have systematic sampling, you have stratified sampling, cluster sampling, and then your non probability sampling has another four types: convenience sampling, judgment sampling, quota sampling, and snowball sampling. So let's understand each one of these. So, in simple random sampling, every member has an equal chance of being chosen. So, for example, let's say you have a list of students. These are my list of students. And you randomly pick 10 names from the list. Maybe you pick up this guy. Maybe you pick up this guy, this guy. You know, it could be randomly pick up any 10 people. So, I'm picking these guys just randomly. So, this is my simple random sampling. Then there is a systematic sampling. Here you select every kth item. K can be any number. So let's say you pick up every third student from a list. This is my list right here. So this is my student 1, student 2, student 3, student 4, 5, and so on and so forth. So I pick up the third student right here, 4, 5. Then I pick up this student right here. This is my third student. And then, so basically this would be my third. This would be another third student right here. Okay. So 6, 7, 8, 9. And you can just keep going like this. So this is your systematic sampling. And then you have stratified sampling. Here you divide your population into subgroups. Another word for that is strata. And you take random samples from each one of these strata. So for example, let's say you want to sample 40 students from a population of 400. That would represent all years proportionally. The key word is proportionally. Here, your strategy would be first, step one, you divide your students by year. So maybe it's a first year, second year, third year, and fourth year. And then you step number two, you sample proportionally. So let's understand this through an example. The first thing you do, you divide by year. That's your step one. So let's say my first year has 120, second year has 100, third year has 80, and fourth year has 100. And my total is 400. Step two, now you want to sample 40 students, right? That's what your aim is. Now 40 is 10% of your total because your total is 400. So 40 of 400 is 10%. So now we are going to take 10% of students from each year. So I'm taking 10% of my 120, right? And the answer comes out to be 12. 10% of 100 is 10. 10% of 80 is 8. And 10% of 100 is 10. And so the total, if you add all the numbers together, the answer is 40. This is your stratified sampling. And now you have cluster sampling. Here you divide population into clusters and then randomly select whole clusters. In this case, each cluster, they should have similar characteristics within themselves. So for example, let's say you want to conduct a survey from students. Here, you divide your students' population into 20 clusters based on the colleges, and then you randomly select 5 colleges. So let's say these are my list of all colleges. Okay, I'm randomly selecting 5 colleges. Let's say C, F, K, N, S, which would be, let's say, this college. I'm selecting this college, and I randomly selected this one, and maybe this one. And then I survey all students in these colleges. So I just pick up these students. That's it. These ones, this one, this one, this one, and this one for my survey. This is cluster sampling. Now back to our problem. So suppose you're a quality manager at a company and you just received a truckload of 10,000 mangoes from a farmer. They're living in east, west, north, south of your country. And your boss says, hey, I want to check if the shipment is good enough so we can export them. Now clearly you cannot cut open all the 10,000 mangoes. So what you do, you only do for 50 mangoes because that's the only time you have. So now question is, how would you pick up those 50 mangoes? Well, since my mangoes came from different region, east, west, north, south, so the quality may differ by source. So what I would gonna do is I'm gonna divide my 10,000 mangoes into 4 strata: north, west, east, south. So let's say my east is 4,000 mangoes, and from the west I got 3,000 mangoes, from the north I got 3,000, and from the south, let's say it is 0 mangoes. Now my 50 is 0.5% of your total. Okay. So what we do, we sample proportionally from each stratum. In other words, we take 0.5% from each strata. So for east side, 0.5% of 4,000 is 20 mangoes. For west side, your 0.5% of 3,000 is 15 mangoes. From your north side, 0.5% of 3,000 is 15 mangoes. And from your south side, 0.5% of 0 is 0 mangoes. You add them all together, by the way, your answer will be 50 right here. Okay. So we randomly select these 50 mangoes within each group. And in this case, we are using stratified random sampling. And now comes the non-probability sampling types. Here you have 4 types. Convenience sampling. In convenience sampling, you choose the sample that is easiest to access. That's where the word convenience comes from. So, for example, you survey people in your school because they're easiest to access. Maybe you're conducting some kind of survey and they will be easy to access for you. Judgmental sampling. Here, you're using your judgment. For example, a research, he selects based on their expertise. So, for example, a doctor chooses patient she thinks represents her clinic best. Maybe her patients are more than 40 years of age. Maybe she has that type of patient. In that case, she's going to choose samples of patients whose age is more than 40. Then you have quota sampling. So in this case, you're making sure that each specific groups are represented. So for example, you may interview 50 males and 50 females regardless of your randomization, because you want to make sure that they are equal proportion, they're equally. And then, of course, there's the last one, which is your snowball sampling. In this case, you participant recruits other. Basically, you take the help of other people, and these are generally used for like hard to reach groups, like for example, rare disease patients. So this is your snowball sampling.